Hello students, welcome back. This question is from GATE 2000 exam and is for 2 marks. They are saying which of the following does not implement the given K-map. This K-map is given in the question. Okay, let's just try to minimize this K-map. So let us start from here. To include this one, you can see we can form a group of 4. Okay. Now let's try to include both of these. First option is you can make a group of 2, but we always prefer the biggest possible group. That is the reason we'll go for a group of 4 like this. Okay. So let us see what's the expression that we're going to get. For these 4, it will be xy plus. Okay. For all of these, the value of x is same, which is 1, y is also same, which is 1. So it is xy plus. Let's now try to find the expression for these 4. It will be w and y. Yeah. So xy plus wy. Okay. So this is the minimal SOP for the given K-map. Okay. That means option B is actually equal to this minimal SOP. That means option B implements the given K-map. B cannot be our answer. Okay. Similarly, you see option A is similar to B. See, this is YW this term and XY this term. So A and B both are same. Okay. That means option A is also implementing the given K-map. Now let's see option C. If you try to minimize this option C, first of all, let's convert it into POS form for simplification. Sorry, SOP form. You have W plus X into W bar plus Y into into X bar plus Y. Let's do one thing. Let's multiply these two. So you will get 0 plus X W bar So this is what you are going to get. Now you can see this is xy and this is xy into w bar. So this term is redundant. Okay, you can delete it. This is wy. This is wy into x bar. This one is also redundant. How? You can use absorption law here. Absorption law says in a plus ab, this term ab is redundant. Okay, a plus ab is actually equal to a. So from here you can see wy plus xy, wy plus xy. Option C is also equivalent to option B. All of these 3 are same. Okay. And we have seen option B implements this K-map. That means all of these 3 will implement the given K-map. And the answer will be none of these. Okay. So your answer to this question is none of these. Now I want to discuss a very important point. They could have made this question a bit more difficult by utilizing this don't cares. Just let me show you one thing. If we want to find the SOP, the sum of products, that means this one, we'll do the grouping like this. But what if we want to find the POS? See, in POS we need to group all the zeros. The grouping will be like this. Okay. And this 0 is left, we can form a group of 4 this way. Okay. Now you see, all these don't cares represent a 0. Whenever we form a group for SOP or POS, in both the cases, see, for grouping all these ones, we have considered these 3 to be 0 only. Okay, because we didn't include any of the don't care. We assumed the don't care to be 0. And while grouping all the zeros, we included all 3 of them and again assumed them to be 0. Here I can include both of them into this group by assuming them to be 0. Okay. So whatever be the grouping, either SOP or POS, we are assuming all of them to be 0 in both of the cases. That is the reason POS and SOP are equivalent. Okay, they could have made this question a bit more interesting by placing one or two don't care such that while grouping for SOP, that means while grouping ones, we include that don't care, and while grouping zeros also we include that don't care. That means at times this don't care is considered to be 1 and at times it is considered to be 0. In that way, both SOP and POS would be different functions, but still both of them would implement this K-map. Okay, so this question could have been a bit more interesting and a bit more difficult. Okay, and they could have also utilized one more fact that, for example, you just see here, this is POS, this one is also POS. A and C, both of them are POS, but option A is minimal POS. This one is not minimal. Like we are grouping, and I'm writing it in blue. Okay, the groupings that are done in blue are for finding out the POS. Okay, and we get option A. Then how do we get this option C? For option C, you will group it in some other way that you don't get minimal, but still you form groups. First indication is you will form 3 groups instead of 2. Here you will form only 2 groups in option A. Okay. See, these are the 2 groups. These 8 are combined and these 4 are combined. These 2 groups are for minimal. You will get options A from here. But for option C, let me tell you the grouping. For option C, I am using red color. Okay. So for this one, I am using red color. You can see we have W plus X. That means W and X both are 0. First group is of these 4. Like this only. Okay. Then is W bar plus Y. W is 1 and Y is 0. That means these are grouped. Now you can see this group is actually not allowed. While grouping, while trying to find out the minimal expression, you won't consider this group because it is a part of bigger group. Okay, this red prime implicant will be a part of this group, this bigger group, so we'll not consider it. But because I want to just show you that this expression could be derived from this K-map, that's the reason I'm doing this grouping. Okay, and next group that will be formed is this one, like this. Okay, so the groupings that I've done in red are for option C. Anyways, we have proved that all A, B, C are equivalent. Okay, so your answer is none of these. Now, I think I've conveyed my point, but still I'll repeat it. If they decided to frame a question by just manipulating these don't care such that both SOP and POS include the don't care condition, in that case, multiple functions could implement this K-map, even though those functions are different from each other. In this case, all these 3 functions are one and the same thing. But don't cares could just elevate the standard of this question. Okay, there could be multiple functions. There could be like 30 functions that are implementing the same K-map. It's possible. Okay, so beware when you have don't cares. Okay.